Okay, so still we are in angles in a triangle. So now we have to prove a different theorem. So let's take the triangle ABC. Now we have to prove that the size or the angles of a triangle, let's say this triangle ABC, BCA and CAB, the uh, total of these three angles should be equal to two right angles. So, what do you mean by a right angle? A right angle is basically uh, 90 degrees. So, the total of the size of these three angles or these three interior angles of a triangle should be two right angles, meaning 180 degrees. So 180 degrees is an angle at a point in a straight line. So this is 180 degrees. So basically we have to prove that the total of three angles in a triangle is equal to 180 degrees or two right angles. So let's get straight to it. Now in this theorem also, let's produce the BC line to D, and then let me draw a parallel line to the side AB. So let me call this E. So here what we have to prove is the total of these three interior angles is equals to 180 degrees. So how do we do that? So now here when a straight line is intersects two parallel lines, again there are angles formed. So here this angle and this angle are equal because they are alternate angles. So let me write that. So BAC is equal to BAC is equal to ACE. ACE. The reason being alternate angles. Alternate angles. Then we have ABC. ABC is equal to, so let me see, ABC is equal to ECD. Why? They are corresponding angles. So let me write that also. ABC is equals to ECD. ECD. So the reason is these are corresponding angles. So these two are corresponding angles. So now again we have two equations here. So I have one equation here and another equation here. So again let me add these two up. Right? So let me add 1 and 2. So what do I get here? BAC. So let's first add the left side of the two equations. BAC plus ABC is equals to ACE plus ECD. ACE plus ECD. Right? So now let's see. So now we have an equation here. So we got two equations and added the two equations, the left sides of the equation and the right sides of the equation. So now in this equation, in the right side we have covered A, CE and ECD. So it's this whole thing, right? And here we have got BAC and ABC. So these two angles. So now what we have to prove is the total of the three interior angles in a triangle. Right? So only remaining in this left side of the equation, the only remaining angle to get our equation is just this angle. So what can we do here? So we can add this angle ACB to this side. So in order to maintain the equality of this equation, if we add ACB to the left side of the equation, we will have to add ACB to the right side also, right side of the equation, because we want to maintain the equality. So let's do that. So let me take, so we are adding ACB to both sides of the equation. So let me take this BAC plus ABC plus ACB equals ACE plus ECD plus ACB. So now we've added. So we have the three angles of a triangle here, three angles of this triangle here on this side, and then we have ACE, ECD, and this angle of the triangle on this side. So these two are equal. Now note this side, ACE, ECD, and ACB. Now this whole thing is actually adjacent angles on a straight line. So, but if you remember what I mentioned earlier, so the total of adjacent angles in a straight line are 180 degrees. So this part of the equation is actually equal to 180 degrees. So let me write that. So ACB, we have ACB, ACE and ECD is actually adjacent angles on a triangle. So this is 180 degrees. On this side of the equation, we have the three interior angles of the triangle. So this side remains the same. So BAC plus ABC plus ACB. So 180 degrees means two right angles or two 90-degree angles. So here we have proven that the interior angles of a triangle, or the sum of interior angles of a triangle, is equal to 180 degrees or